All right, welcome to the fifth lesson for chapter 10. In this lesson, we're going to focus on two new renewable energies, at least that we're learning about, and one is geothermal, the other is tidal power. So the learning objective is that you will be able to describe how we harness geothermal and tidal energy and the possible negative impacts of both. All right, so let's talk about geothermal energy first. So geo means like earth, rock. Thermal meaning warmth, so it's warmth from the earth. So in geologically active areas, hot magma moves to the surface and heats water. So like in areas that have like volcanoes and active magma going, this is where geothermal energy is coming from. So that hot water then can heat buildings or generate electricity through a steam turbine. So if the water is heated enough, that is, it's boiling, it's producing steam, and it's turning to a gas, then that gas is going to turn the turbine, and that can generate electricity. Wells can be drilled to obtain steam that's trapped underground, and the steam powers electrical generators, and that's kind of what this guy looks like. So we can send the fluid, the water, back down to be recycled, and then it gets heated, and then that steam is pumped back through, turns a turbine, we get electricity, and it's sent back in. The U.S. produces about 25% of the world's geothermal electricity. So of all of the electricity that's produced through geothermal energy, we produce 25% of it. However, geothermally produced electricity is less than 1% of the U.S.'s electrical consumption. So it is a very, very small part of where our electricity actually is coming from. So for limitations, heat pumps can be used in areas that are not geologically active. So it's not just where we have hot magma running like closer to the surface. It can be used in other areas. The pump that just extracts heat from the earth and deposits it into a building. It's not always the most efficient or cost effective, but there's not great limitations on it. It's just the ability to like drill into the earth to get that heat up. So environmental issues that come with geothermal energy is the steam that's produced from this, that's being released from the earth, often contains hydrogen sulfide gas. It smells not good. It smells like rotten eggs, and the minerals in the steam corrode pipes and equipment. And the minerals are also toxic to fish. So smells not great because it's eroding the pipes and the equipment. That means that those pipes and equipment are going to have to be replaced very frequently. And then if we're eating the fish that are living near these plants and the minerals are being released are toxic to the fish, and that's not great for us. And also, as we've talked about in this class, we want to preserve the natural world around us, also just for the natural world. So it being toxic, not great. So there's very few environmental issues with heat pumps, but there are a few. All right, so this is a geothermal power plant. So this is where electricity is actually being produced. And then this is a geothermal heat pump system. So we're collecting that hot water, hot steam, hot whatever from the earth. It is warming the home and then going back down. All right, so let's talk about tidal power next. So this is different than hydroelectricity. Hydroelectricity is coming through a dam. Tidal power is using the tide going up and down or in and out to generate electricity. So certain coastal regions experience higher tides than others. We don't have an ocean, so we don't have a tide. But if you've been out to one of the coasts, hopefully you knew that the tide goes in and out. So those tides are not always equal. Some tides go in and out more or up and down more than others. But for tidal power to make sense, to produce practical amounts of power, there needs to be a difference between high and low tide of at least 5 meters, which is 16 feet. And a dam or barrage is built across a tidal bay or estuary, and that's what this guy is right there. There are a lot of limitations here because the number of suitable sites for this is very, very small. This isn't something that can be done everywhere. Now, related to tidal power, but not exactly the same, is an actual, like a tidal current system. So in tidal power, we have this, it looks sort of like a dam that's built across, that goes up and down with the tides, and that movement generates electricity. With a tidal current system, we have these kind of wind turbine things. So changing tides create strong ocean currents in some locations. Again, we are limited in where this can happen, but in some locations, that movement of the tide in and out is a really strong movement of water. And wind turbine-like machines can be placed on the seafloor. Only one system like this exists, and that's north of Scotland. But it's kind of cool. All right, so environmental issues that come with tidal power. The barriers in the turbines affect the migration of fish and other marine species. Like, these are turbines that are along the ocean floor, so if that's normally where fish and other species are swimming, that's an issue. If we look at this dam across, we are, no matter what spaces are underneath that, we are disturbing the natural movement of the organisms through that water space. So again, this would be a normal like tidal power station that kind of just looks like a dam or a barrage across the water. And then this is a tidal stream or current setup, which only one currently exists. All right, that is the end of this lesson. Please let me know if you have any questions, and I will see you in the next one.